Okay, so we're going to look now at another case of finding the equation of a circle, and this time we're looking at the equation of a circle where we're maybe given a tangent and the point of contact and one other point on the circle. Okay, so it's again another different type. So we're using that same ideas that were introduced in the last video, so that kind of general introduction to finding the equation of the circle. So that's definitely one to kind of even just catch the start of if you're unsure. So we're going to look at, again, the two different methods I have, so one geometric, one kind of algebraic here. So a circle has the line y equals 2x as a tangent at the point 2, 4. The circle also passes through the point 4 minus 2. Find the equation of the circle. So what we're kind of looking at, I suppose, here is I have my circle, I have my line, which touches my circle at one point, which is the point 2, 4. I want to find the equation of the centre. I have another point, which is 4 minus 2. That could be, I suppose, literally anywhere. In terms of my question here, that could be literally anywhere. We might put it down here. So 4 minus 2. And because I want to answer this geometrically, I'm going to be making use of what I know about chords, what I know about tangents, what I know about all of that. So one of the things that we know is that if I have a chord formed between 2 points here, the line perpendicular to the chord will pass through the centre. So if I was to find the perpendicular line there, and we'll give it a name, we'll call it J, that line would pass through the centre. Similarly, if I could work out the perpendicular line perpendicular to that tangent to x, that would also pass through the centre. So I'm going to call that one K. Okay, so let's approach it in a similar way to what we had in the last question. So J is this kind of perpendicular line there. It needs to be perpendicular to these 2 points, 2, 4 and 4 minus 2. So let's find the slope of those two. So minus 2 minus 4 over 4 minus 2. So that's minus 6 over 2, which is minus 3. So therefore the perpendicular slope, or the slope of J, will have to be 1/3. Okay, if it's going to be a bisector, I'm going to also need the midpoint. So 2 plus 4 over 2 and 4 minus 2 over 2. So that's going to be, let's see, 6 over 2, which is 3, and 2 over 2, which is 1. So the midpoint 3, 1, slope 1 over 3, y minus 1 equals mx minus x1, y minus 1 equals 1/3 x minus 1, multiplying by 3, 3y minus 3 equals x minus 3. So x minus 3y equals 0. Okay, so nice simple equation there for us for the moment. Okay, looking then at the next bit that I have here, so that's going to be the equation of k. To find the equation of k, we have to maintain or kind of use the fact that it has to be perpendicular to this line, this tangent line that I've been given. So because I know the equation of that tangent, okay, y equals 2k or 2x, I need to get the slope. The slope is just the coefficient of x, so 2. When it's written in that format, it's written in y equals x plus c format. So the slope is just 2. And I need a point on that line as well. It's not a bisector this time, I just need a perpendicular line to this tangent, but it has to go through my tangent point. So the point I'm going to be using is the point of tangency 2, 4. So y minus 4 equals mx minus x1. So y minus 4 equals 2x minus 4. So y equals, and what is that going to leave me with? It has to be perpendicular, which I forgot to take. So that's minus half here, which of course is going to change our answer here. So you can see it's very easy to go too quickly with some of these questions, which I am very prone to. So 2y minus 8 minus x plus 2. This is looking a bit more like something that I was expecting. X plus 2y is equal to 10. Okay, so that's my second equation of the line here. Now I know that the centre will be the point where those two lines intersect. X plus 2y equals 10. So let's do minus 1 of the first one. So minus x minus plus 3y equals 0. X plus 2y equals 10. So I get 5y equals 10. Y equals 2. X minus 3 times 2 equals 0 means x equals 6. So my center here is 6, 2. Okay, so my center there is 6, 2. The radius is going to be the distance from the center to one of my points. So I can pick any of my points. So say the center to the point 2, 4, for example. So that's going to be x2 minus x1 squared plus y2 minus y1 squared. So that's 4 squared plus minus 2 squared, which is 16 plus 4, which is root 20. So equation of the circle, x minus 6 squared plus y minus 2 squared equals 20. And you can kind of see here, hopefully, the pattern that's emerging, which is for the geometric ones, where we maybe find where we find points of center and then the radius, we go for this kind of shorter, or I suppose that kind of more contained version of the equation of the circle. And when we look at the next type or the next method, that other alternative method for that same example, the more algebraic one, we're expecting maybe we'll end up with that longer format for the equation of the circle. So we're going to look at kind of similar again, where we're using any of the information that we have here about my circle. So I have 2 points that I know are on the circle. So that's the point 2, 4 and 4 minus 2. So let's look at each of those points in turn. 2, 4 being on the circle means I can sub it into the circle and it should satisfy the equation. So 2f minus 2 plus c equals 0. So 4 plus 16 plus 8g minus 4f plus c equals 0. 8g minus 4f plus c equals minus 20. The second point we need, 4 minus 2, okay, is 4 squared plus minus 2 squared plus 2g times 4 plus 2f times minus 2 plus c equals 0. 16 plus 4 plus 8g minus 4f plus c equals 0. 8g minus 4f plus c equals minus 20 also. Okay, so I'm ending up, now I've done something wrong there. I feel there's something has gone off. Oh, I've swapped my points here accidentally. That makes sense. I swapped my points here accidentally. Let's just fix that one up before we move on. So 4g here and minus 8f there. That makes more sense. I was kind of thinking we shouldn't end up with the exact same equation there, because those would be 2 different points subbing in. They would have different ratios going on there. Okay, so ending up with both equal to minus 20 though. So 4g minus 8f plus c and 8g minus 4f plus c. Excuse me, that should be actually even be plus 8f as well. Okay. We've got it fixed. We've got it fixed up. So taking those 2 points, we could use those then to write an equation or to form a simultaneous equation, which would reduce down my information ever so slightly and kind of bring it down into some other format. But before I do that, I want to see what other information I have. And this is where I kind of said at the offset as well that even though we're approaching the algebraic idea, we can't always just disregard the geometric side. Okay, and where this kind of comes in, I suppose, is that same thing we had here originally. If I have a tangent, that tangent is going to be perpendicular to the radius at that point of tangency. So if we can find the equation of that, say we call it k, if we can find the equation of k, then the center is going to be on that line. So we're using a similar method, but with a different, I suppose, end goal here. So find the equation of k. Well, the slope of k is going to be perpendicular to 2, so it's going to be minus a half. We know the point it has to be on is the point 4 minus 2. Okay, so we're finding this equation that we already or 2, 4, excuse me. We're finding this equation that we already found. Okay, 2, 4. Y minus 4 equals half x minus 2. So y minus 4 equals half x plus 1. 2y minus 8 equals minus x plus 2. X plus 2y equals 10. Okay, x plus 2y equals 10. Now, what I know about this is the center has to be on this line. The center has to be on this line. My center is minus g minus f. So I'm going to sub that into my equation of the line. And again, it should satisfy the equation of the line, or it would if I knew what g and f were, which I don't in this case. So bearing all of that in mind, I now know that I have an equation at the end that has only g and f. So looking at my first 2 equations here, I'm going to set out to kind of get rid of c. So that's 4g plus 8f plus c equals minus 20, and 8g minus 4f plus c equals minus 20. I'm going to multiply this bottom one by minus 1. So 4g plus 8f plus c equals minus 20, and minus 8g plus 4f minus c equals 20. So that's going to give me an answer of minus 4g plus 12f equals 0. Okay, minus 4g plus 12f equals 0. Okay, so making use of that, I suppose, then we're going to kind of line that up with my other equation that I have here, which is minus g minus 2f equals 10. So that's my yellow equation that we had here on the side. So again, I'm just going to set out, pick one of my letters. So I might multiply the bottom one by 6 here. So minus 4g plus 12f equals 0, minus 6g minus 12f equals 60. So that's going to give me minus 10g equals 60, and g equals minus 6. Okay, g equals minus 6. I can use that then to find f. So minus g minus 2 f equals 10. So minus 6 minus 2f equals 10. 6 minus 2f equals 10. Minus 2f equals 4, and f equals minus 2. Okay, so f is minus 2, g is minus 6, and I can use that then to go back and find c. So 4 times minus 6 plus 8 times minus 2 plus c equals minus 20. So minus 24 minus 16 plus c equals minus 20, and c is equal to, so let's see what that gives me overall here. So minus 20 plus 16 plus 24 is going to give me 20 overall for c. So summing all of that back into my equation of the circle, I get x squared plus y squared plus 2 times minus 6x plus 2 times minus 2y plus 20 equals 0. So I get x squared plus y squared minus 12x minus 4y plus 20 equals 0. Okay, as my overall equation of the circle. So same equation, as I said from before, same equation if we multiplied out that shorter format as well, we would get the same equation for both cases. Okay, so that's our second kind of case where finding the equation of the circle, this time given the equation of a centre, a line on which the centre, or a tangent line, and another point on the circle.